Good morning, everybody. My name is Kathleen Hernandez. I'm an application engineer with TriStar, and today we're going to be talking about Mathcad Prime. Specifically, I'll be working in Mathcad Prime 4.0, so if any of you guys are on an earlier version, either Mathcad 15 or Prime 1, 2, or 3, or 3.1, you guys will see Prime 4.0 in action, which looks very similar to the previous Prime releases. Before I get started, I wanted to let everyone know that there's a TLO, time-limited offer on Mathcad through September 30th. If any of you guys find this presentation interesting and you want to go ahead and purchase it, looks like you get a little bit of a deal through September 30th. And our agenda today, we're going to do our basic Mathcad Prime 101 demo. I'll run through it quickly for those of you who have not seen the latest version of Mathcad Prime yet. But today I want to focus more on the integration with Excel, getting data out of Excel into Mathcad and utilizing that information. In previous webcasts, I do the basic 101 demo, but I focus on different things. For example, the last one, I focused on the integration with Creo Parametric. So please go check out the TriStar's YouTube channel or TriStar's website for all of the webinars that we've conducted, not only with Mathcad, but Creo Parametric and Windchill, which is our data management tool. So I think a lot of you guys will find that interesting. So the challenges in leveraging engineering knowledge, especially with mathematic calculations, how are you guys capturing that math? Is someone writing on their notebook next to their design and they throw away the notebook when they run out of paper and time for a new one? You know, how are we able to capture and reuse that data? We all know that math is what makes the world go round, right? So let's go ahead and utilize it and capture it and put it in a readable format. That's half the battle. If we can create documents that are presented in natural math notation in a way that we learned it in 6th grade, let's say, a square root symbol is a square root symbol, then that would be very beneficial, not only to the author who's creating the document, but especially to the reader who's reading that document. But then additionally, you have the ability to document your equations, which I think is very powerful. You can bring in plots and charts, and you can just make a very readable calculation worksheet. So let's just jump right into it. Here's Mathcad. This is Mathcad Prime 4.0, and what I'm going to show you basically is, let's run through the interface, units awareness, natural math notation. We'll put in a couple plots, the documentation aspect of Mathcad, and I'm going to focus on the integration with Excel, show you guys a couple examples of how to read in Excel or utilize the Excel component. We can briefly discuss the integration with Creo Parametric. I do have a couple slides at the end of this slide deck that I can run through quickly, but again, I went through in depth in a separate demo the integration with Mathcad and Creo. So, go check out the previous webcasts that we have available. And I think not only will you run into that one, but you'll run into a lot of other information that you might find valuable. So let's talk about the interface. Mathcad Prime, we've got the ribbon interface, just like everything else is going to the ribbon interface. So the Math tab is everything to bring in math. I can bring in math, I can bring in text. There's different operators in here, symbols, programming. As far as the operators, this equation break is new in Prime 4. So if you have a really long equation, you can essentially, quote-unquote, wrap the text of that equation, either an addition, subtraction, multiplication, or division. And that allows you to display the entire equation, it might, on one page, it might be a little bit broken, but that's exactly what these equation breaks are for. So that's new in Prime 4. Again, we've got symbols. If you want to define your variables with Greek letters, you can do that. Programming, you don't need to know programming in order to know Mathcad Prime, but you can create programs. And I like to think of a program as a multi-line function. That's how I like to think of programs in Mathcad. We've got different constants in here that are predefined. For example, C is the speed of light. Okay, we've got some symbolics that are very useful. I'll show you guys the explicit keyword in a little bit, but if you wanted to float certain number of decimal places, you can definitely do that. You can expand. Remember the FOIL method back in school? You have all of that stuff. Okay, we have units awareness inside of Mathcad. We'll be discussing that shortly. The input-output allows us to integrate with Excel. So I'll be coming here later on in a demo to use the read Excel function and bring in the Excel component. You also have the ability to run the converter. So if you are still working in Mathcad 14 or Mathcad 15, you are not able to open up those files directly in Mathcad. What you need to do is you need to convert them into Mathcad Prime files. So you need to run the converter. And I have a little trick in this slide deck that I'll mention a little later if you only have one license available. Because what you need to have is you need to have Mathcad 15 MO10 or later and Mathcad Prime. And if I run the converter from this icon, it's going to use a second license. And so there's a workaround if you only have one available that I'll mention. We have a Functions tab that has all of the functions in different categories. Feel free to come in here and explore some of these different functions. Or you can list all of the functions and it'll pull it up on the left-hand side. And you have the ability to search for that specific function that you're looking for. Matrices and tables is where we would come in here and create matrices or maybe define our variables as tables. And once we have that created, we can come in here and very easily manipulate the rows and columns of those matrices or tables. The Plots tab allows us to bring in plots with multiple traces if you need to. And once you have a plot enabled, you have the ability to manipulate the look and feel of the traces and the plots. We've got math formatting and text formatting, two separate tabs, which is very helpful if you want your math to stand out differently from your text. You might want it to look the same. You might want it to look slightly different to differentiate between documentation and mathematics. And so you have the ability to format those slightly differently if you'd like. The Calculation tab allows us to manipulate maybe the origin of our matrix. The default is 0, 0. That uppermost left-hand value of a matrix is the 0 column, 0 row, but you can change that from 0 to 1, which could influence some of the calculations in your worksheet. So it's important to understand what that does. And then auto calculation is on by default, meaning if you change the value of any of your variables, it'll automatically push those new values down the worksheet, quote unquote, regenerating the worksheet. Okay. However, you might have some complicated calculations. It might take a little time to run through those calculations, or you need to make several changes at once and you want to propagate it all together. You can stop the calculations, make all of your changes, and then manually calculate the worksheet, more for performance reasons. You don't want to have to sit and wait every time you make a change for it to propagate through, especially if you want to make several changes. All right, we've got the Documentation tab. This allows us to show a grid or not. Maybe you don't want to see the look of that engineering paper. You can change the grid size from standard to fine. This is one of those things I would probably, one of those decisions or settings I would make pretty early on in the document creation. I have it set to standard, and I created my agenda. I'm going to switch it to fine. And you can see how that moves all of my notes closer together. And if that's what I wanted, great. But that's not how I created it. I created it with standard, and this is the look I was going for. So just mentioning that changing this setting from standard to fine does change the look of the document that you're seeing. And so that's a decision I would probably make fairly early in the document creation. We've got a page view and a draft view. The draft view is what we had in Mathcad 15 by default. And this line down the middle is your page margin, your printer margin. The page view is essentially your print preview. You can scroll out and you can see this is that page that would be printed out. Okay, so down here in the lower right-hand corner is that scroll bar where you can manipulate the zoom level. We can create headers and footers if we'd like, which is great. You can manipulate all of these settings and save it out as a template. Maybe you create a new Mathcad worksheet with your company letterhead and some page numbers and the date at the bottom. Save it off as a template, and every time we create a new document, we want to utilize that one to standardize the look and feel of our engineering calculations. We definitely have the ability to do that in Mathcad. And then this last tab is resources, where there's just a lot of help. And we've got references, tutorials, you have the Mathcad Help, the keyboard shortcuts if you wanted to print out that page. You know, as a new user, you might want to print that out. As you're using Mathcad, you'll become familiar with what those keyboard shortcuts are. But there's really a big PTC community out there that I think is extremely helpful. And a lot of people really like to share their work, to share their knowledge. And even if you guys get a chance to go to some of the user groups, and especially if they have a Mathcad presentation, I always learn every time I go to those user groups from industry. What are you guys using the tool for? And just seeing how Mathcad has integrated into their systems is always a lot of fun to see. So that's all available in this resources tab, right? So if you guys go to ptc.com, there is a 30-day trial where you get full-blown Mathcad for 30 days. After 30 days, the full-blown version expires, but you get an express copy where you can do simple math, right? You can probably do some addition, subtraction, but you might not be able to integrate with Excel. So some of the full-blown features are cut off. If any of you guys are interested, send me an email. I'll display that at the very end of the presentation, and I'll find a matrix of what's included in the full version and what's included in the express version. All right, let's talk units. Units is very powerful inside of Mathcad. Excel, which I'm going to be talking a little bit later, doesn't have units awareness, right? So if I wanted to come in here and add 5 feet plus 6 inches plus 2 meters plus 19 furlong, when I hit equals, Mathcad automatically recognizes all of those as units of length, and it gave me my answer in units of length. So one of the things I want to point out are the units, so it automatically go to a bold blue. That's how it recognizes it as units. Right, so I'm going to copy this a couple times. All right, if I wanted my answer in inches, all I have to do is get rid of meters, type in IN for inches, and it automatically converted the result to inches. If I was doing any data transfer, we have all these PDFs from our math from 40 years ago when we didn't have any soft copies of anything, and so what we're going to do is we're modernizing all of our documents, and we're going to be putting them into Mathcad. Well, as I'm doing my data entry, instead of M, I accidentally type N. Mathcad recognizes that N is not units of length, and so it does not erroneously calculate a result, especially if it was propagated later on in the worksheet. This is very powerful. It's not going to give me the wrong value. So I can always come back in here and, oh, I realize I accidentally put in an N, type in M, and it calculates it all for us. We have our unit systems up here, SI, the US customary, and then centimeters, grams, seconds. If I were to go to the US customary, it will convert the entire worksheet to feet, pound, second, except for this one. It's in inches because I explicitly typed in inches. So because I said, I explicitly told it I wanted in inches, it didn't convert that one. If I want to go back to the default, what I typically do is I just delete it and re-evaluate it to go back to the default units. Let's talk natural math notation. If I wanted to add 356 plus 34, it would be very easy to divide just that last number by 3. Is this what I was looking for? Maybe. But if I wanted the entire numerator to be 3, denominator, I can definitely do that. So if I said 356 plus 34, I want the entire denominator as 3. That would give me a different result, right? If I hit equals here versus equals here, completely different results. And I think in Excel, you can very easily make this mistake if you're not careful. Gotta use your parentheses in here. But with this natural math notation, you can very easily see what is obviously the numerator, what is obviously the denominator. Let's go back to our square root sign. In Excel, you have to, the square root is to the power of 1/2. Well, now I'm assuming that the reader knows that the square root is to the power of 1/2. Inside of Mathcad, we can just define it. So I'm going to define C. So the colon equals, that's our definition statement, okay? And I'm going to go ahead and make C the square root of A squared plus B squared. Got our Pythagorean theorem in here. Okay, well, I haven't defined A and I haven't defined B. So let's come over here and let's define A to be 20, and let's define B to be 36. So one of the things I want to mention is Mathcad reads top down, left to right. So I had mentioned earlier that C is the speed of light. So I'm redefining C to be the square root of A squared plus B squared. Before this new definition, if I were to evaluate C, C, you can see it's the speed of light. Just to show you, if I'm using the default constant, I don't know if you guys can see this very well, but that C is in a green color, and then we have our units in blue. I'm redefining C to be the square root, and it's not in that green color, it's just regular black. So if I evaluate C underneath this new definition, or to the right of it, it's now, what is it, 20, the square root of 20 squared plus 36 squared, which we can come in here and show our work if we want. We have a keyword. Let's explicitly show with respect to A and B what the values are. And we can evaluate this all in one line if we'd like. So if the value of A were to change, you'll see that automatically updating our results. integrals. I don't know if we have a lot of people who are doing calculus on this call, but you've got integrals in its natural math notation, and we can solve definite integrals and indefinite integrals. So what I've been doing so far is I've been solving numerically because there's a value here. But if I wanted to find the integral of sine of x dx, there's not a definite solution. So what we can do is we can symbolically solve for that value, and this is the true value. Right? Let's come back in here and call this f of x. So I'm retroactively assigning it to a function. We can always plot this if we'd like. So I'm going to come over here, bring in a plot, and because I was off the page, it automatically transferred the look and feel to the draft look. But let's go ahead and put x along the domain and f of x for the range. You can see there's our plot. And you can add many traces if you'd like. Let's make g of x equal to the integral of f of x dx, and symbolically solve for that. And if you hover over one of those keys, it'll tell you what the hotkey is. So if I were to use the control and a period, that would give me the arrow. Okay, so you can see the integral of negative cosine of x is negative sine of x. And if I would like to add that as a trace, I'll go to the plot tab. I'll say add a trace, and let's bring in g of x. It's highlighted in red because the plot is actually starting above the new function. So I'm just going to drag it down slightly, or maybe move this function up. Let's move it up over here. There we go. Now you can see the g of x in here. And when you activate the plot, that's when you have the ability to configure it. So what do I want the plot background to be? If I say transparent, then you'll see the engineering paper behind it. If we say white, then the plot, the trace, has a white background. How do you want this to look? Okay, it's totally up to you. You have the ability to manipulate the traces. So I've got g of x active. I'm going to come in here and make this a red trace, and let's thicken it up a little bit. We have the ability to add vertical and horizontal markers. So I'll add a vertical marker, and I can either drag this to a specific location, or you can type in, you know, I want to look at the marker at pi divided by 2, and it'll automatically move the marker to that spot. Easy, easy stuff. So you can see I created my agenda at the beginning of this demonstration, and I've been moving around these labels as I present that specific topic. So let's go into the documentation. So I've got labels. I didn't do the best job documenting, but I happen to have a document over here that's complete, and it's got the nice header, titles. We've got a nice description of what this document is supposed to convey. We've got an image in here that was imported. They're defining our variables and then defining what these variables represent. Being able to document what your worksheet is trying to accomplish, I think, is very powerful, because you're not the only one who might be using this particular document. We want to know why you came up with the particular solution. It's like creating a program. For anybody who does any programming, if you're standing on the shoulders of giants and you're reusing a program that somebody else created, it's so helpful when it's documented inside the program. It's commented out what the next set of lines is doing. And so very, very powerful to come in here and document your work. One of the things I do want to mention that I haven't mentioned in any of the previous webcasts is you've got a text block and you have a text box. A text box it's like a Post-it note. Control T is just the hotkey. Okay, if I were to Post-it note, I could, technically come in here and start typing, and it would accidentally go over some other math. Okay, I'm just kind of being dumb with my notes here. But you can see how it's overwriting some of the math that was already there. Right? That is a text box, like a Post-it note. A text block, what it does is it automatically adds that block across the entire page, and it moves the math with it. So if I say text block, you can see it expands over the page, and as I hit enter, the rest of the math beneath it moves down. So you can add documentation wherever you want without writing over your previous work. If anybody wants to jump out early. There's my email address, Kathleen.Hernandez@TriStar.com. All right, but you can see as I'm hitting enter, the rest of the worksheet below it is moving down. Okay. All right, let's talk Excel. So Excel, there's really two main ways to integrate with Excel, but I'm going to say three. So I happen to have a worksheet here opened up. One of the things you can do is if I were just to copy and paste, let's say these values, so I'll do Control C, let's come into Mathcad, I'm going to do a Control V. What I would be doing is I would be bringing in these values as a table. So I'm really defining variables. Let's call this X and let's call this Y. I don't know if that's smart. Let's call it Z and Y because I have an F of X up above and that might cause some issues. So Z is now equal to a vector and Y is equal to a vector. A vector is a one-column matrix. All vectors are matrices, but not all matrices are vectors, right? Okay, so if I were to just do a copy and paste, this is the results you would get. That may or may not be what you were looking for. So we have got some more formal ways of bringing in Excel. We have the read Excel function. All right, when you do the read Excel, it opens up this dialog box and you can browse to a previously created worksheet if you'd like. So this is the preview of the worksheet that I'm bringing in. I'll say open. By default, it will bring in the entire range of the worksheet, but you can specify what columns and rows you want to bring in. I'll bring in everything. I'll go ahead and hit insert. And what I'm going to do is I'm going to name this data. So if I were to say data equals, you can see that we've got our table in here. If I wanted to say that A is equal to data, and then I could do a column extraction of 0, you can see I'm just pulling out that subset of data. So A equals that column, and then I can multiply it or utilize it somewhere else in my math. So I'm capturing the data in Excel, but I'm manipulating it in Mathcad, and I can always add units to it if I want. I could add it here. Times feet. Okay, guess not. But I think you can add it over here, feet. Nope, guess not. Darn. Okay, I'm missing something here. I know you can add units here. And I knew you could multiply it. So I must be missing something. If you're interested in units, send me an email and I'll reply back to you with, this is what I did wrong. All right. I don't necessarily need to display this data though. That's what's nice about the read Excel. So let's go back to our slide deck real quick. The read Excel function, it imports dynamically. I can store this Excel worksheet in a central location, like the shared M drive, if I'd like. Not everyone has access to Mathcad, but almost everybody has access to Excel. So maybe that we're capturing the design in Excel, but manipulating the information in Mathcad. Okay? Mathcad worksheet updates accordingly to updated source data. So if we were to modify that Excel sheet, when we open up Mathcad, you would see the updated data, thus propagating all the information through our Mathcad worksheet. No need to display the source data in the Mathcad worksheet. So in this example over here, I just wanted to show you when I evaluate data, it is that information, but I don't need to do that. Okay, if I wanted to define this variable A, I would still need to bring in that column function, column extractor function, but I don't need to display what the data matrix is initially. And you can generate plots with units from source data without storing data in Mathcad. You can do this. Mine failed. I'll work on that later. We're going to keep it moving though, okay? But you do have the ability to bring in units. We also have the Excel component. What's nice about the Excel component is you're embedding Excel within Mathcad. So with the read Excel function, you've got two separate files. You've got your Mathcad file and you have your Excel file. I would probably store them in a similar location just to keep that link happy. But I only have the Mathcad file with the embedded Excel component. So it might be a heavier weight file, but I only have one file that I need to manage. And that's pretty powerful. So the spreadsheet is stored inside the Mathcad file, and you have the full functionality of Excel, including macros, lookup tables, all of that. So I'm going to come into Mathcad, and what I'm going to do is I'm going to bring in this information. So I'm just going to highlight everything. Let's copy. All right, and we're going to create an Excel component. Okay, by double-clicking in the cell, that launches Mathcad. And I'll go ahead and paste. Right, and I'm going to go ahead and utilize the Mathcad formatting. So let's come in here and let's give it a table feel. And when just by closing this worksheet, you're adding that information into Mathcad. You have the ability to, you have inputs and outputs. Outputs, what do you want to output from this table? So there's a couple different ways you can do this. You can either type it in directly. So I'm going to bring in, so I'm defining row to be the B column. So from B2 to B6. So I'm using Excel nomenclature here. And then if we'd like, we can add units. So let's multiply that by kilograms by cubic meters. Right? So if I come over here and say row, so and what I'm doing is I'm typing in the Roman equivalent. So R Control G. Control G makes it that Greek letter, equals. And my units are in the US customary, so it's pounds per cubic feet. That's what it's displayed in. I can always change that to SI units, and it would list what you see in the table. Right? So we could, oh, another way to import. So I typed it in manually. You can also right-click for menu, and you can insert an output expression. So you get that much already for you, which is kind of nice. You don't have to type in as much. And so let's define that to be C2. Okay. Utilize that for any mathematical equations. You also have the ability to input stuff into Excel. So up here, I'm going to define hardness to be a matrix. Let's do maybe a 5x1 matrix. Right? And I'm going to come into the inputs. I'm going to right-click and insert input expression. So what I'm going to do is I'm going to find the next column. So A, B, C, D, E, F. So I'll say F2 to be equal to hardness. That's what I named the variable. Okay, so if I were to double-click the table, you'll see that we've added this additional column in here. Might need to rename it. But it's included. And you know what, we can definitely sort, close it out, and include it in our table. So this is what I really mainly wanted to show you. Don't worry about the information that's in the table, but I'm focusing on how do I get information into the table and how can I extract information from the table. You can also come in here and simplify, minimize your outputs field. You can minimize your inputs field. So all you have is this nice looking table with your math underneath it. Right? So you just click the table and you can expand if you want to see the expressions in your input and outputs area. Okay, so this is a little bit more in-depth on the Excel piece than I typically go. I kind of mentioned that you can integrate Excel, and I move forward. So hopefully you guys got some more information as far as how you can integrate with Excel. I was watching a YouTube video the other day, and the gentleman did a read Excel function and then displayed it in his Excel component, which I thought was interesting. I don't know if there was any circular references that were created, but as far as his input goes, he called, he read out his, well, I called mine data, right? And so there's the epsilon and the row parameters that I read in from my read Excel function. And if I were to double click it in here, I'm manipulating not the raw data. I'm manipulating the Excel sheet in here. And so once I come in here and do that, that's something I would probably test on your end. There might be a circular reference that might be an issue. If I manipulate it in here, what happens to the raw data, but you're reading in the raw data, so I still need to do some additional testing on that. But it was kind of interesting to watch that presentation. You can create plots from this data. You can create customized summary table of results, and everything is stored in Mathcad. So you don't need to have that separate Excel worksheet. I mentioned earlier the converter. If you still have some Mathcad 14 or 15 files, you need to convert them in order to open them up in Prime. If you only have one license available, then close all of Mathcad, and you have to have Mathcad 15 MO10 also installed in order to run the converter. But when you go dig into where the converter is located, so navigate to where Mathcad Prime 4 is installed and run the converter standalone, and it'll only utilize one license, and that's how you can convert some of your documents. There's some nice literature under resources. I think it's under references. There's a migration guide that will walk you through that entire step. Don't get too concerned when you open up the migration guide and it's 70 pages. The first 10 might be applicable on how to use the tool, but the remaining pages kind of give you results. If it looks like this, it's because of that. And so there's some nice feedback in this migration guide. For those of you who already know Mathcad, there's a what's new. Feel free to take a look at that. But I also have a what's new in Mathcad Prime 4 specifically. So this is only covering the delta between 3 and 4. That equation breaking is new. We were able to create areas, but now we can protect areas. They've reintroduced that. We are able to protect areas in Mathcad 15, and a lot of people may have been hesitant to move into Prime because they weren't able to protect those. That was reintroduced in Mathcad Prime 4. Support for Windows 10. Some of you guys might be cheering on the line. This is probably one of the most frequent call I get was, you know, we've upgraded to Windows 10 and Mathcad won't work anymore. Prime 4.0 is the answer. You can save as a rich text format. You know, so you can open up this file in Word. They're just images. So if you were to change the Mathcad data, you would have to re-export that rich text format file, right? It's not going to update dynamically, but that's pretty powerful because not everybody has Mathcad, but almost everybody has Office to utilize Excel, Word. OpenOffice is free. You can open it up in there. And then you got Rourke's formula for stress and strain, 6th edition that they've converted over into Mathcad Prime 4. I think that one's at a cost, but very useful for those of you who need the templates for stress and strain calculations. This slide is a little dated, but what I'm trying to emphasize here is Mathcad 15 is still supported. Do I have that? Yes. Here's the product calendar from PTC's website. Everything that is in Mathcad 15 has not made it into Prime yet. There's very little that has not made it into Prime. Prime is good for the majority of our customers. In fact, we encourage you to go to Prime. But there may have been some very complicated worksheets that were created in Mathcad 15 using features that are still only in Mathcad 15. So PTC has not ended the support for Mathcad 15. They will end the support of Mathcad 15 when all of the features in Mathcad 15 have made it into Prime. So at least Prime 5.0, might even be farther, but Mathcad Prime 4 is a great release, and I think aside from the interface change, which might be a big enough reason for people not to take the plunge. I know, change sucks. But if you're able to make that leap into Mathcad Prime, I think a lot of you guys will be very happy with it. Easy to use, intuitive. I've got a couple slides here on the engineering notebook but and the engineering notebook is what allows you to combine your mathematics with your engineering design in the CAD tool. Our CAD tool is Creo Parametric, and you can seamlessly integrate your math with your design, utilizing relations and parameters, and as you update the math, the design updates. It's pretty cool. And I have a demo of that we recorded earlier in the year, available on TriStar's website, tristar.com, or TriStar has a YouTube channel. If you guys are subscribed to the YouTube channel, do so. You'll get notified when we upload new videos. All of our webinar topics are posted on there. So if you're interested on how to integrate with the CAD side, take a look at it. It might be pretty interesting. All right, so we have a chat window if you guys have any questions. All right, so I'm going to read some of them here. Is Excel integration only available with Mathcad Prime, or is it also available in Mathcad 15? It's also in Mathcad 15. And so again, if you YouTube and Google, what did we do without them? If you YouTube Excel integration with Mathcad 15, you'll get a couple hits, and very, very useful. Oh, I'm getting some corrections on my units, so I think that's helping out. I'll definitely take a look at that. Thank you so much. Does Work use the ebook feature that's similar to Mathcad 15? Because Mathcad 15 had those library books, right? And I think it's similar. It's probably not exact ebook, but I can get back to you on that, David. Let me get back to you and exactly see that. I think what it is it's probably a zip file with a bunch of files that are labeled accordingly, and you can open up the file and save it out as a template if you need to use it over and over again if needed. Okay. All right, so, no hyperlinks. Well, let me look into that, because I haven't really looked into the libraries on the Mathcad side of things. I have converted the old Mathcad 15 libraries. I migrated them into Prime, and not all of it was nice and pretty, but it was pretty useful. So that might be an option as well. But if it's already converted into Mathcad Prime 4 with the nice layout and you don't have any of those conversion problems, it might be worth looking into. Let me do a little homework on that. And if you guys wake up in the middle of the night with any burning Mathcad questions, my email address is kathleen.hernandez@tristar.com. If I need to do any follow-up with you guys, send me an email. And I'll reply back to you. What's nice about that is it gives me your contact information directly. So I hope you guys enjoyed this presentation. It'll be on YouTube a little later on today if you guys want to re-watch this. And thank you very much.